In this lesson, we're going to be looking at angle properties of quadrilaterals. And this is going to be a short video, but it's going to lead into the next video, which is dealing more generally with all types of polygons. The outcomes we're going to cover are: describe and illustrate angle properties of quadrilaterals, explain using examples why a given property does or does not apply to certain polygons, identify and explain an application of the properties of polygons in construction, industrial, commercial, domestic, and artistic contexts, and solve a contextual problem that involves the application of the properties of polygons. So we're going to give a few definitions to start. A diagonal is a line segment connecting two non-adjacent vertices in a polygon. So in other words, two vertices that are not joined together to help create the polygon. Here we have a quadrilateral, ABCD, and we have a line segment drawn from vertex A to vertex C. This is what we'd call a diagonal, because A and C are not adjacent vertices. Also, if we were to draw a line connecting vertex B to vertex D, again, that would be a diagonal because it's connecting non-adjacent vertices. One last thing. You'll notice that the diagonal AC divides quadrilateral ABCD into two different triangles, triangle ABC and triangle ADC. Just a reminder of some terms that you're probably very familiar with, but I'll remind you anyway. A square is a polygon with four-sided polygon, of course, with all sides equal in length, and all the angles in this square are also equal in length, and they all have a value of 90 degrees. In a rectangle, all of the angles are equal. They're all valued at 90 degrees each, and opposite sides are equal. Not all sides, but opposite sides. A square is a special version of a rectangle. So in this case, all the sides would be equal, but that's not the case with every rectangle. Next, we have an isosceles trapezoid, and that's a four-sided figure with one set of sides parallel and the other set of sides equal in length. So it's a trapezoid because there's one set of parallel sides, and a trapezoid will only contain one set of parallel sides. And it's isosceles, much like in an isosceles triangle. In an isosceles triangle, there are two equal sides. Well, in an isosceles trapezoid, there are also two sides equal in length. And those sides are always the pair of non-parallel sides. Finally, we have a parallelogram. A parallelogram is a four-sided figure with two pairs of parallel sides. And the opposite angles in a parallelogram are equal in measure. So that would be, for instance, if you're looking at the angle in the bottom left corner and the bottom right corner. So this angle right here and this angle right here, they would be equal. This angle right here in the top left is going to be equal to this angle right here in the bottom right. So opposite angles in a parallelogram are equal to each other. And the sum of the angles in a quadrilateral, we can find this if we were to take a protractor and measure all four angles. But in a triangle, we said that the sum of the angles is going to be 180 degrees. Well, in a quadrilateral, it can be made by combining two triangles. Like we said, triangle ABC and triangle ADC in this case, will be put together to make trapezoid, quadrilateral ABCD. As a result of putting two triangles together, we find that the sum of the angles in any quadrilateral, doesn't matter the shape, what the angles are, what are the side lengths, as long as it's a four-sided figure, it's going to be true all the time, and that's that the sum of any of the angles in any quadrilateral is 360 degrees. And that's the same as the sum of the angles in the two triangles that would make it up. So to quickly summarize, the sum of the angles in any quadrilateral is 360 degrees. Any quadrilateral can be made by combining two triangles. A square has all right angles, 90-degree angles, and all of its sides are equal. A rectangle does also have all right angles, so all the angles are equal, they're all 90 degrees, and opposite sides are equal. An isosceles trapezoid has one set of parallel sides, and the non-parallel sides, the other pair of sides, are always going to be equal length. That's what makes it isosceles, one pair of equal sides. And finally, a parallelogram has opposite sides parallel to each other, and opposite angles are going to be equal. And like I said, this is a short video. It's more to give you a few definitions. And we're actually going to tackle some problems that deal with these properties of quadrilaterals in more depth in the next section. Or sorry, in the next video, which is included in this section.